Ask how the brain experiences joy, and you will almost certainly hear dopamine. The cultural consensus is that it is our dedicated pleasure chemical. This assumption drives the narrative in medical textbooks and underpins the behavioral logic of the tech industry, where social media loops are engineered specifically to trigger dopamine hits. In the final stages of addiction, the drive to consume becomes a compulsion divorced from joy. Patients will spend their lives pursuing a substance that no longer provides a subjective high. If dopamine directly causes pleasure, the ultimate dopamine-driven act should result in intense enjoyment. Instead, it yields none. Affective neuroscience treats reward as a composite of three separate systems: liking, wanting, and learning. First, there is liking. This is the actual hedonic impact, the core objective pleasure experienced in the exact moment of consumption. Second is wanting. This is a non-conscious motivational drive. It is the raw biological urge to pursue a specific goal. And third is learning, the system that builds predictive associations and memories around future rewards based on past experiences. To understand pleasure and the mechanics of addiction, the drive of wanting must be separated from the sensation of liking. Modern neuroscience often falls into a specific epistemological trap, assuming that because a brain region lights up during a pleasant event, it is actively generating that pleasure. This graph illustrates neural coding. The orbitofrontal cortex, or OFC, tracks pleasantness perfectly, but doesn't create the joy. We see this during selective satiation. As you become full, a food's value declines, and the OFC computes this drop in real time. Yet historical data from prefrontal lobotomies shows that patients with profound damage to the OFC still retain the capacity to experience basic sensory pleasure. The intense cortical coding is present, but it is not strictly required. To isolate pleasure generators, neuroscientists differentiate between necessary and sufficient causes. A necessary cause means without it, normal pleasure vanishes completely. A sufficient cause means activating it magnifies a pleasure reaction far above normal levels. Trusting functional imaging alone blinds us to this distinction. The actual physical generators of pleasure are not located in the expansive, glowing cortex, but are hidden deep below it. Moving downward from human cognition, we reach evolutionarily ancient subcortical structures. Here, researchers have mapped specific hedonic hotspots. These are tiny neural hubs located primarily within the ventral pallidum and the shell of the nucleus accumbens. These hotspots are microscopic. Each one measures roughly a cubic millimeter in a rodent brain, occupying a strikingly fragile fraction of total brain volume. To verify their function without human language, scientists measure objective liking reactions in non-linguistic mammals. They look for homologous affective facial expressions. Across species, from mice to macaque monkeys to human infants, sweet tastes elicit tongue protrusions, while bitter tastes trigger gapes. Micro-injecting drugs into these subcortical hubs drastically amplifies those positive facial expressions, but the chemicals that trigger them are opioids and endocannabinoids. Dopamine is completely bypassed. Core pleasure is a biological reflex generated by a delicate, ancient opioid network shared across mammalian species, operating entirely independent of higher-order cognition. If the opioid hotspots are generating liking, we are left with a massive dopamine network. We have to ask what it actually does. The definitive test of dopamine's function came in the 1950s and 60s with the advent of deep brain stimulation and the infamous pleasure electrodes. In one highly documented case, a young man known as patient B19 received an electrode implant that directly targeted his dopamine-heavy pathways. B19's behavioral reaction was extreme. He compulsively self-stimulated the electrode thousands of times a day. He neglected personal hygiene, abandoned family commitments, and violently protested when the button was taken. Despite this frantic behavior, B19's self-reports lacked any mention of actual pleasure. The electrode triggered a raw urge to continue, but never a hedonic satisfaction or high. What the electrode induced is known in psychology as incentive salience. This is the precise non-conscious motivational drive that dopamine mediates. Dopamine acts as a biological highlighter. It tags specific stimuli in the environment, rendering them irrationally attractive and demanding their immediate pursuit. The B19 case demonstrates that dopamine does not dispense joy. It dispenses desire, a biological imperative that operates aggressively even without a hedonic payoff. The anomaly of patient B19 perfectly mirrors the pathology of clinical drug addiction. This diagram contrasts a healthy brain with neural sensitization, a condition where psychostimulants induce permanent hyperreactivity in the dopamine system. Over time, the drug suppresses the fragile opioid-liking hotspots, deadening the capacity for actual pleasure. Simultaneously, it permanently supercharges the dopamine-wanting network. This creates a pathological state defined as irrational desire. The individual compulsively wants a reward they neither like nor expect to like. Because this subcortical drive operates beneath conscious awareness, it easily overpowers the addict's conscious, cognitive desire to quit, housed in the prefrontal cortex. Addiction represents a neurological hijacking of the brain's motivational hardware, leaving the victim driven by a biological imperative that offers no hedonic payoff. Stripping pleasure down to subcortical hardware raises immediate questions about the human pursuit of happiness. Early psychoanalysts held a purely hedonic perspective regarding our motivations. For it operated on a basic premise: human happiness is a mathematical equation achieved by maximizing pleasure while strictly avoiding displeasure. But this human-centric philosophy clashes with the grim evolutionary reality of our shared mammalian hardware. Evolutionary survival prioritizes wanting over liking. Nature requires organisms to be hungry, searching, and highly motivated to secure resources, rather than permanently satisfied. It is true that our cognitive capacity, specifically the orbitofrontal cortex, layers cultural richness and subjective awareness over basic mammalian liking. Human cognition vastly expands our sources of pleasure, from art to social bonds. Yet the core hardware generating that pleasure remains stubbornly conservative, which leads to a neurobiologically accurate definition of true bliss. It is a state of intense, localized liking that is entirely free from the relentless, dopamine-driven noise of wanting. Affective neuroscience reveals that happiness relies on separating these two systems. It requires silencing desire long enough to satisfy the quiet, ancient hotspots of true contentment.